NCERT Physics, Class 11th, 5th chapter, which is Laws of Motion, question number 5.13. A man of mass 70 kg stand on a weighing scale in lift which is moving, case 1, upward with a uniform speed. So in first case, the lift is moving in upward direction with a speed of 5 meter per second, constant speed of 10 meter per second. So a person is standing in the lift on a weighing machine. So we have to define in first part what would be the reading on the scale in each case. So in order to define the reading in each case, reading means the normal read by the weighing machine. So in this we have to define the reading of weighing machine. So in order to find the reading of weighing machine, first find normal by weighing machine on person, then divide it by G. So in different situation, you are supposed to find the normal between the person and the weighing machine. So coming to first part. So in first part, the lift is moving with uniform speed. So in particular direction, magnitude is constant. This implies that acceleration is zero. So in order to make the free body diagram of the person, we can say that the force acting on it is normal, which is by weighing machine, mg, gravitational force. So acceleration is zero. This implies that net force would also be zero. And if net force equal to zero, normal is equal to mg. So mass of this person is equal to 70 and g is equal to 10 meter per second square. This implies that normal is equal to 700 Newton. Now, in order to find the reading of weighing machine, we have to divide the normal force by g. So reading is equal to normal by g, which is equal to 700 by 10, which is equal to 70 kg. So in first case, the reading of weighing machine would be 70 kg. Now coming to B part, if the lift is moving with uniform acceleration in downward direction and acceleration is 5 meter per second square. So in again B part, again we have to find the reading of weighing machine. So whenever you need to find the reading of weighing machine, you first find out the normal by weighing machine on the person and divide that normal by z. So in this case, the normal in this reaction is equal to nb. Gravitational force is mg. As lift is moving in downward direction with acceleration of 5 meter per second square, so as we all know, the net force will be in direction of acceleration. So net force is downward direction. So we can say that net force is equal to mg minus of normal in case B. Net force can also be written as m into acceleration. So mass of person is given and acceleration of person is same as acceleration of lift. This can be written as, so from this we can find the value of normal in case B, which is given as nb is equal to m. When this will come this direction, it will be negative sign and g m will be common. So we have nb is equal to m into g minus a. So in order to put the value of m and g, we have nb is equal to, that is normal by lift, that is equal to 70 into 10 minus acceleration, that is 5. So this value comes out to be 350 Newton. So again, in order to find the reading, divide this 350 by g. So reading would be, so in B case, reading would be 350 by g, which is equal to 35 kg. So in second part, the reading given by normal machine, weighing machine, is 35 kg. Coming to third part, C, upward, when the lift is moving upward with uniform acceleration 5 meter per second square. So it is just similar to part B, just in this direction of acceleration is reversed. So first you draw the FBD. The force acting is normal by lift in case, let's say this is case C. So we will use NC. Downward direction mg. In this case, the acceleration is in upward direction, so net force should also be in upward direction. So we can write as F net is equal to NC minus mg. So net force in the upward direction can also be written as mass into acceleration. So in this case, we have NC is equal to mg plus A, and the value of m is 70 and g plus A is equal to 15. So NC is equal to 70 into 15, which comes out to be 1050 Newton. Now, in order to find the reading, for reading, what we have to do, you have to divide the NC with G. So reading is equal to 1050 by G, that is 10. So reading is equal to 105 kg. So in C part, reading given by weighing machine is equal to 105 kg. And now moving to last part, which is D. What would be the reading if the mechanism failed and fall under gravity? So in case of free fall, we know that in case of free fall, acceleration of lift is vertically g downward. In case of free fall, acceleration of lift is g in downward direction. So in this case, the lift is moving in downward direction with acceleration z. So we can use as in case B, we did this is normal in D part mg. So in this case, the acceleration is in downward direction, which is equal to g. So net force equal to m into a. Net force is equal to m into acceleration, which is g, can be written as mg minus n into d part. So clearly from this we can say that normal by reading, normal by lift in this case is equal to 0. This implies reading by weighing machine will be 0.